So today we're going to look at linear inequalities. Let's get straight into it with a question. Here we have three inequalities, that's what they're called when you have these special arrow looking signs, and we want to represent them on a number line. So we're going to go through what they all mean and how they work. So part A, it says x, this funny sign, 7. What this sign means is that x is greater than, because this part here is the wider, greater part, it's greater than 7. To represent this on a number line, we just have to find where it says 7, and we draw a circle. And then we have to get out our ruler, and we just draw a line like this, get rid of our ruler, and then draw an arrow. And what this tells us is that x is greater than 7. It can take any value larger than 7, but not 7 exactly, which is why we leave the circle unshaded. For part B, we can see it's the opposite. Instead of the wider part being towards x, it's the smaller part. And we also have this little thing here. What this tells us is that x is smaller than or equal to -8. So x could be -8 or anything smaller than it. So in order to represent that, we go and find -8 on our number line, and we draw a circle, but then we fill it in to explain that x could also be that number. Then we get out our ruler, and we draw a line going in the other direction because we're looking at smaller than. And then we draw an arrow to show that x is equal to or smaller than -8. And for the final question, part C, we have -3 is less than x, but x is also less than or equal to 4. So we need to represent all of this. The way to solve this is to look at both ends of the inequality and to circle them on our graph. So for -3, we're going to find -3, and because it's a less than sign and not a less than or equal to sign, we're not going to shade it in. But for the 4 on the other side, we are going to shade that in. And then we're going to get out our ruler, and we're going to join these up together to show that x can take any value between -3 and +4. And this is how you represent inequalities on a number line. Now we know how to do that, we're going to look at solving inequalities. The way you solve inequalities is almost identical to the way that you solve regular equations, but there's just a different sign there. So let's give this a go. We want to solve 3x minus 2 is greater than 16. We want to find out what x is greater than. So we're going to write this out. 3x minus 2 is greater than 16. Now, it's just now like solving an equation. We're going to add 2 to both sides, so we get 3x is greater than 18. And then to get x on its own, we're going to divide by 3, so we know that x is greater than 6. And we know that to present this on a number line, we draw a circle, unshaded because it's equal to, and then we draw a line like this, and an arrow to show that x can be any value greater than 6, but not equal to. The final question looks at when you have this double inequality, where 2x minus 1 is both greater than or equal to 5, or less than 9. So, the way to solve this is to split it into two parts. The first part is that -5 is less than or equal to 2x minus 1. So let's solve this. We're going to add 1 to both sides, so we get -4 is less than or equal to 2x, and then divide by 2. So we know that -2 is less than or equal to x. And that's our first inequality. To tackle the second one, we have to look at the other half. So we're going to do 2x minus 1 is less than 9, and then we solve this. We add 1 to both sides, so 2x is less than 10, and then we divide by 2. So we know that x is less than 5. And now we have these two inequalities. To draw them on a number line, we just do the same thing, like we did with the double one up above. We know that x is greater than or equal to -2, so we do a circle shaded in for the equal. And we know that x is strictly less than 5, so we do an unshaded circle. Then we get out our ruler, and we connect the dots. You may have also noticed that we have to state all the integer values that solve the inequality. Now, an integer is just a whole number, so it could be 2, it could be -5, it could be 8, that's all an integer is, it's a whole number. So to state all the integers, we use set notation. Now this is just a fancy way of saying we do this fancy bracket like this, And then we just list every number, every whole number that x could be. So x could be -2, it could be -1, it could be 0, it could be 1, it could be 2, it could be 3, it could be 4, it couldn't be 5 because x is strictly less than 5, it can't be equal to. So these are all the integers, and to finish it off, we just close the bracket with another one of these weird squiggly things. And that is our answer. That's it for solving linear inequalities. In the next video, we're going to look at showing this graphically.